How satellites provide internet, the future of global connectivity. In a world where high-speed internet is essential, satellites are revolutionizing global connectivity. From rural areas to disaster zones, satellite internet is bridging the digital divide. But how does it work? Let's explore the technology behind satellite internet and its impact on the future. How does satellite internet work? Satellite internet operates by transmitting data signals between satellites orbiting Earth and ground-based receivers. Here's how the process unfolds. 1. User request. When a user clicks a link or streams a video, the request is sent from their satellite dish or receiver to an orbiting satellite. 2. Signal transmission. The satellite relays the request to a ground station gateway connected to the main internet infrastructure. 3. Data processing. The ground station retrieves the requested data from the internet and sends it back to the satellite. 4. User delivery. The satellite transmits the data back to the user's receiver, completing the process in milliseconds. Types of satellite internet systems. 1. Geostationary satellites. GEO. Altitude 35,786 kilometers above Earth. Latency approximately 600 milliseconds. Higher delay. Providers: HughesNet, Viasat, Pros, wide coverage, stable connections. Cons: slower speeds, higher latency. 2. Low Earth orbit satellites. LEO. Altitude 500 to 2,000 kilometers above Earth. Latency approximately 20 to 50 milliseconds, much lower. Providers: SpaceX, Starlink, Amazon Kuiper, OneWeb. Pros: faster speeds, lower latency. Cons: requires a large satellite network for coverage. 3. Medium Earth orbit satellites. MEow. Altitude 8,000 to 20,000 kilometers. Latency approximately 100 to 150 ms. Providers: O3b networks. Pros: balance between coverage and latency. Cons: limited availability. Advantages of satellite internet: global coverage. Reaches remote and underserved areas where fiber or cellular internet is unavailable. Quick deployment. Essential for disaster recovery, military operations, and emergency response. High-speed access. With LEO networks, users can experience speeds up to 1 gigabit per second. Reliable backup internet. Works as a fail-safe when terrestrial networks fail. Challenges of satellite internet. Weather interference. Signals can weaken due to heavy rain or storms. High equipment cost. Satellite dishes and receivers can be expensive. Limited bandwidth. Network congestion can affect performance in high-demand areas. The future of satellite internet, with SpaceX's Starlink, Amazon's Project Kuiper, and OneWeb investing billions into LEO satellite constellations, the future of high-speed, global internet is closer than ever. Soon, autonomous vehicles, IoT devices, and smart cities will rely on satellite networks for seamless communication. Watch our viral video on how satellites provide internet. Want to understand how satellites are changing the internet landscape? Watch our latest video breakdown. Watch now and don't forget to like, comment, and subscribe for more space and tech content.